Welcome to The Explainer. Okay, I am absolutely thrilled about today's topic. We're looking at a brilliant strategy aimed at completely rebuilding our global food system. But get this, we aren't talking about massive tractors or thousands of acres of farmland here. We're talking about the microscopic level, literally rebuilding the food system from the molecule up. We're going to explore the invisible infrastructure that actually makes our modern food supply chain tick.
So, let's just dive right in and anchor ourselves to the real-world stakes. $1 million. Big Idea Ventures has just deployed exactly $1 million across 5 distinct food tech startups for their Global Food Innovation Fund 2. That gives each of these companies a super crucial $200,000 investment package plus access to a huge accelerator network. Now, I know, $1 million might not sound like a ton of money in the wild world of global venture capital, but as we'll see, it's exactly where and how this capital is being deployed that makes it absolutely game-changing.
Here's our agenda for today. 1. Rebuilding the food system. 2. The less but better thesis. 3. Innovating from the molecule up. 4. The commercial viability hurdle. And 5. Scaling for emerging markets. Let's get into it.
All right, Section 1. Rebuilding the food system, moving beyond the farm.
We really need to shatter this old myth that feeding a growing population just means, planting more seeds and clearing more land. The reality and the core thesis driving these investments is all about extreme efficiency. True food security doesn't actually hinge on just growing more crops. It hinges on losing less of what we do grow, getting way more nutritional value from less input, and, this is key, dramatically lowering the cost of advanced food science so people can actually afford to use these solutions.
To pull off that kind of efficiency, Big Idea Ventures is going after the most stubborn, financially draining pressure points in our supply chains. They're targeting ingredient scalability, meaning ensuring we can actually mass produce the things we invent. They're tackling cold chain integrity, which, as we'll see, is a massive global vulnerability. And they are directly attacking the crazy high costs of bringing food biotechnology to the open market. They aren't trying to boil the ocean here. It's more like precision acupuncture, hitting the exact pressure points that cause the whole system to lock up.
Moving to Section 2, the less but better theses, maximizing input efficiency.
You see, science itself really isn't our main roadblock anymore. Carolyn Mock, the Senior Director of Acceleration at Big Idea Ventures, points out that this cohort is taking a less but better approach to food, and they are explicitly tackling one of the industry's biggest barriers, cost. That framing is everything, right? This entire group of startups is designed specifically to smash through that barrier of prohibitive expense.
So, what does that actually look like in practice? Well, these companies aren't out there building flashy, branded consumer products that you'd grab off a grocery store shelf. Instead, they're constructing foundational food system infrastructure. They are building a horizontal layer of enabling technologies. Think of these as the underlying tools that will dictate what's actually possible for the food manufacturers and brands that eventually do reach us, the consumers. It's literally the plumbing and the wiring for the future of our food. Section 3. Innovating from the molecule up. The startups changing the microscopic game. Looking at this group, you've got this amazing mix of both geography and hardcore science. Each company is attacking a totally distinct molecular vulnerability in our food system. You've got BioClé operating out of Argentina and the US, working on a bacterial extracellular vesicle platform for the targeted delivery of bioactives. Try saying that 3 times fast. Then there's CryoVera in France, who are busy inhibiting ice recrystallization. RheaPlant in the US is mastering plant cell biomanufacturing, and Saku Biosciences, also in the US, is engineering high-yield bacterial strains to basically fast-track food products to market.
Let's demystify the science just a bit and look closer at RheaPlant's plant cell biomanufacturing. This is a proprietary tech that produces really hard-to-source botanical ingredients. But the real magic? They can do it consistently, all year round, and at significantly lower costs. This directly solves a massive structural vulnerability. Food manufacturers across Africa and Asia know exactly what I'm talking about. Traditional botanical sourcing is totally at the mercy of seasonal changes and geopolitical disruptions. But this tech essentially guarantees a stable supply, completely bypassing those traditional farming headaches. Or take this anti-crystallization molecule developed by CryoVera. This tiny little molecule literally stops ice from recrystallizing during transport. Now, why on earth does that matter? Well, because it directly combats cold chain degradation. When temperature-controlled transport fluctuates or fails, which happens all the time, ice crystals form and absolutely ruin premium food quality and texture.
According to the source material, this degradation is actually one of the most financially damaging yet completely underreported problems in global food logistics today.
All right, Section 4, the commercial viability hurdle. Moving from proof of concept to profitable.
Andrew D. Ives, the founder and managing general partner of Big Idea Ventures, framed this entire million-dollar deployment beautifully. He said the focus is on commercial viability rather than idealism. And he makes it crystal clear, if you want to rebuild the food system, you need pragmatic, money-driven solutions. You need technologies that can actually bridge that massive gap between a cool proof of concept in a lab and a shelf-ready product that, actually makes economic sense.
And that vision is translating into real-world confidence. It's not just VC money backing this. Big Idea Ventures is supported by massive corporate players like AAK, which is a huge established name in food ingredients, and Buhler, a literal giant in processing machinery. That is a massive signal of validation. These aren't just attached investors, these are industrial operators with deep, everyday supply chain exposure. They're looking at these microscopic innovations and saying, yeah, we absolutely need this right now.
So the takeaway here is pretty stark, and it's something you really have to keep in mind. The single most consistent reason that food innovations fail to scale is not because of scientific limitations, it's commercial unviability. I mean, if you can't make the science affordable and profitable, it really doesn't matter how brilliant the biological breakthrough is. It's just never going to feed the world.
Which brings us to Section 5, Scaling for Emerging Markets, the global impact of microscopic tech.
So we really have to ask ourselves a huge question here. How does a bacterial strain engineered in some US lab or an anti-crystallization molecule cooked up in France actually impact the sprawling, complex food ecosystems of a place like Africa? To answer that, we have to look at Africa's current supply chain reality. The continent's food value chain is definitely not lacking raw material or agricultural output. That is absolutely not the problem. What it consistently lacks is the what comes next part. Access to ingredient processing tech, reliable temperature-controlled cold chain infrastructure, and cost-effective domestic biomanufacturing that can operate at scale. So while the raw output is absolutely incredible, the continent takes a huge hit with massive operational losses just because this infrastructure is missing. And that is exactly the gap these startups are designed to fill.
The current reality means sky-high operational losses for African food processors, big retailers, and exporters simply because of those physical logistical hurdles. But look at the future state. Instead of spending decades and literally billions of dollars trying to pave perfect traditional cold chain roads across a massive continent, we can use microscopic solutions like CryoVera's stabilization molecule or RheaPlant's biomanufacturing to essentially leapfrog and bypass those missing physical infrastructures entirely.
The strategic playbook for this is honestly fascinating. The plan isn't just to drop these brand new, super expensive technologies directly into emerging markets right on day one. No, the strategy is to perfect them and prove them out in Western markets first. As they go through cycle after cycle of commercialization, those costs are naturally going to drop. And once they become cheap and reliable enough, boom, the window for massive, scalable deployment across Africa blows wide open. Trust me, food manufacturers and agribusiness investors on the continent are tracking this stuff very, very closely.
Which brings us to a really provocative question I want to leave you with today. If the absolute future of global food security depends on rebuilding our supply chain from the molecule up, are we truly ready to invest our capital and our focus into the infrastructure that we can't even see? It's a pretty wild paradigm shift, right? Moving from tractors to molecules and from pure idealism to actual commercial viability. Thank you so much for joining me on this explainer today. Keep looking closely at the invisible systems around you.